First of all, I want to thank the organizers for having me. Today, I'm going to talk about homology planes and contractible for manifolds. Homology spheres are closed-oriented three manifolds having the same integral homology of the three sphere. Here we look at specific homology spheres called Kirby-Ramanujan spheres, and they bound both homology planes and Maser or Pointer type contractible for manifolds. The first example of a homology plane was found by Ramanujan, and today this object is known as Ramanujan surface. In the 1980s, Kirby also observed that the boundary of this surface bounds a Maser manifold. So this is the historical motivation behind our definition, and since then this example has remained a single example. One can construct the Ramanujan surface by looking at some line arrangements in the complex plane. Basically, it is blown up of a complex plane at the point P, and eventually one can find these dual graphs. If your homology planes are just integral homology planes, then you can just think this dual graph as a plumbing graph. After Ramanujan, several techniques appeared in algebraic geometry. Here we study Tom, Dick, Petri, Zeidenberg, and Guryar-Mienishi type homology planes. As you see, we have three infinite families called Xn, Yn, and Zn. What we did is basically we proved that the boundaries of Xn, Yn, and Zn bound Maser or Pointer type contractible for manifolds, so they are Kirby-Ramanujan spheres. These are the first additional examples after Kirby and Ramanujan. These spheres are links of the singularities in complex space, but at the same time they are Seifert fiber spaces. Here we look at their third singular fibers. We supply these two special families, and we also observe that this supplies is diffeomorphic to our Kirby-Ramanujan spheres. And the base case, n equal to 1 case, corresponds to the supplies of Poincare homology sphere and the Briscoe sphere 237. Our results are interesting in both algebraic geometry and low-dimensional topology because, first of all, our homology planes cannot originate from the links of the singularities. But Briscoe spheres always have minimal resolution dual graphs. Since the 1980s, we know that Briscoe spheres may bound Maser manifolds or contractible for manifolds. However, we cannot realize them as the boundaries of homology planes due to Oreko. But our result says that their supplies may bound both these complex surfaces and for manifolds. Recall the homology cobordism group. We don't know the algebraic structure of this group completely, but at least it is very complicated, and we know that it has infinite rank summands. Our Kirby-Ramanujan spheres are automatically trivial in that group. However, we first realized that our Briscoe spheres are separately linearly independent in that group. In fact, the second family generates an infinite rank summand. Also, it is geometrically different than the previous families. So yeah, that's all I want to say today. Thanks again for having me. Thanks for your attention.